Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. To Sir Muhammad Afdal bin Samsudin. Today, our group would like to present the People Launcher Design Challenge, which is the assignment for this semester. My name is Muhammad Amar Bakir bin Zul Nazruddin. I would like to present the introduction for this assignment. In a projectile motion, there are two simultaneous independent rectilinear motions. Along the x-axis, uniform velocity responsible for horizontal, which is forward motion of the particles. Along y-axis, uniform acceleration responsible for the vertical, which is downwards, motion of the particles. Next.
My name is Muhammad Shazwan. I will introduce the mechanism of the launcher. The piece of wood is used to make sure the design is tough. The PVC pipe is set to 35 degree, act as ping pong base launcher. The rubber band give power to launch the ping pong ball by pull back until the space between the ping pong ball and the ground is 6.1 cm. The ice cream stick is to make sure the ping pong ball does not slip when launched. The string is used to make sure the ice cream stick are released at the same time. Let's watch a video as a proof.
Right, next.
Okay, hi, my name is Sarah and I'm going to show you the calculation on how to achieve the desired target from point A to point B. There are 6 steps and the idea is we need to find the initial velocity and also the time of flight so that we can determine the elongation of the rubber band. For the first step, we assume for x-axis, it is positive to the right and y-axis is positive upwards. We use this equation to get the v0 or the initial velocity. R here is referred to the distance from point A to point B, and we need to resolve the V into x and y axis since there is an angle which is 35 degrees. Second, we use this equation so that we can substitute the value of V0 into it and we can get the time of flight in second. We need to substitute back into the previous equation for V0. Next, we construct a graph of forces versus elongation to find the gradient K. This is because we need the K value to substitute into the conservation energy equation, just like the step number 6. And finally, we can get the elongation required, which is 4.32 centimeter.
All right, next.
My name is Nafara Fariza, and for discussion, when the ball is launched, the only forces acting are gravity and air resistance. Gravity accelerates the ball in the negative y direction. Air resistance accelerates the ball in the opposite direction of travel. It observed that when the arm of launcher was pulled back until reach the lower brake, it will stretch the rubber bands. The energy will be stored once we pull back the arm launcher within the rubber band. And after that, when we let go of the arm launcher, this stored energy will be converted into energy and the projectile begin to fly. The more energy that give at the projectile, the further it will travel. When the angle launched is set at 35 degrees, it shows that the ping pong ball will be land in the ground faster and the time of projectile travel will be shorter.
Right, for the conclusion is in order to create the ping pong ball launcher, drag coefficient need to be determined that would help in calculating angle to launch the ball. Last but not least, calculate the theoretical value for drag parameter followed by perform an experiment to determine experimental value. So that's all from us. Thank you very much.